We are recording. Okay, so this week is really all about descriptive statistics. Now, these notes are in the Google Drive. If you want to read through them, it's going to give you a bunch of information that I'm just going to, skip on through. I'm just going to talk about the stuff really quickly. I mean, I think we all know what the mean is. We all know what the median is. We all know what the mode is, right? These are three different measures of center. The mean is the average that we're used to. The median is just the middle number. When you have your numbers in order, it wouldn't make sense if you didn't order your numbers from smallest to biggest, and it's whatever sits right in the middle. If you have an even number of numbers, then it's going to be the average of those two numbers. So like if you think about having four numbers, like hold up your four fingers and think of those being four numbers in order, the median is going to be right in between your second and third finger, right? It's going to be the average of those two middle fingers, whatever those numbers are. If you have an odd number of numbers, right? So now add your thumb in there, and now you've got five numbers, including the thumb, then your middle finger, right, ends up being the median because it's got two numbers below it and two numbers above it. That's just how the median works. And then, of course, the mode is the most frequent data value, and you can have no mode, and you can also have more than one mode. So here's some simple examples, right? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that 1, 2, 3, 4, 5, this 7 right here is our median. It's got 4 below and 4 above. But down here, we've got 1, 2, 3, 4, 5, 6, 7. We only had 8. So the median is going to be right here in between the 4th and 5th. And you would take the average, and the median of this one would be 7.5. Not going to bother doing any more examples of that. Frequency distributions, you can use these to figure out what your median is, right? Because if you just add up all of these numbers, 2 plus 5 is 7, 7 plus 4 is 11, plus 2 more, right? 13, plus 1 more is 14. So we know the 7th and 8th number they straddle the median, right? There's 14, so there's 7 below, 7 above. So right there between the 7th and 8th number, we would have to average it. Well, there's 2 here and 5 here, so that's 7 numbers. So the 7th number is a 2, the 8th number is a 3, so the median would be 2.5. You can do the same thing with this example, right? You could, okay, there's 40 of them, so as you count them up, here's 5 and 8 is 13. 13 and 9 is 22. Since there are 40 of them, we know that the median sits between the 20th and the 21st, right? And we know that the 20th and the 21st is in this class. So all we can say is that the median is in the 40 to 50 class. And what people normally do if they're working with this kind of data and they don't actually know what the raw data is, they just have kind of these results, then they'll just take the average and they'll say the median is 45 because that would be the midpoint of this class. So that's just how you'd have to deal with that kind of bad data. And that is horrible data because you don't actually know what the real numbers are. Cross tabulations, you guys need to pay attention to this because your mini project will ask you to make cross tabulation tables, and people keep screwing them up. So let's take a second to make sure we understand how a cross tabulation table works. All a cross tabulation table is, it's a fancy way of saying you've got some data that is going to be categorized two different ways. It's going to have a horizontal categorization, which in this case is your class rank, and then it's going to have a vertical classification, and the vertical classification was how they lived, right? Did they live on campus or off campus? So this is cross tabulation data. Now, you normally only do cross tabulation tables with non-numerical data. So nominal, right? Or you could do ordinal as well, but nominal and ordinal level data. And we can see that this is technically ordinal level, right? Because there is a ranking to these, right? Freshman comes first, then sophomore, then junior, then senior. And then this would just be straight nominal because it's just basically you lived either off campus or on campus. And so you use a cross tabulation so you can see that there were 42 sophomores who lived off campus, and there were 48 who lived on campus. Therefore, there were a total of 90 sophomores, and so on and so forth, right? It's just a way of showing you that type of data. So any questions so far on measures of center and cross-tabulation tables? We all good? Can everybody see my screen? Hopefully, I'm not just talking into a void.
Yes.
Okay, thank you, Mary Beth. All right, next. Standard deviation is really just how wide your distribution is. We've talked about the 68, 95, 99.7 rule, which is called the empirical rule. And that tells us that if you go one standard deviation in both directions from the mean, right? The mean is represented by the black line here in the middle of both of these normal curves. One standard deviation in both directions represents the red color. That represents 68% of your data. You can see this is much wider than the one on the left. If you go two standard deviations out, so you include the red and the green for both, that's going to give you 95% of your data. And then if you go three standard deviations, so include all three colors, red, green, and blue, that's going to give you 99.7%. These are rough estimates. They're pretty close, but they're rounded. So you can see that the standard deviation on the left is much thinner than the standard deviation on the right. And you need to think of a standard deviation as a unit of measure, right? When you get a standard deviation, when you have a bunch of data and you run the data and it comes back and it says, hey, your standard deviation is 3. Well, think of that 3. Sure, it's a distance. It means that you have to go 3 points above and 3 points below from the mean, and that gives you 68% of your data. But that standard deviation is also just a unit of measure, and it just so happens that your unit of measure has a length of 3. So it's the difference between having a unit of measure in inches, or having a unit of measure in feet, or having a unit of measure in centimeters, right? These are all different ways of measuring a different length. Well, in this case, you can have standard deviations that are all different lengths, right? So we'll talk about things in terms of standard deviations. It was 2 standard deviations above the mean. Well, what does that mean? Well, it means it was sitting right here, right? And it means it's right on the cusp of, that's basically the 95%, right? There's 95% in between these. So it's sitting right here. If there's 95% in between, we know there's 5% everywhere else. So we know there's 2.5 above and 2.5 below. So if it's sitting right there at 2 standard deviations above, we know it's basically the 97.5 percentile. Right? There's only 2.5% above and 2.5% below. There's all these little things that we can kind of draw together, and they all tell us the same story. But I just want you to, start thinking about standard deviations in terms of spread. A small standard deviation just means you have a tall, skinny distribution, not necessarily a normal curve. Whatever your distribution is going to be tall and skinny. And then if you have a large standard deviation, then you're going to have a short and wide distribution. Again, it doesn't have to be normal. Whatever that distribution is, it's going to be short and wide. Okay, so some examples with small standard deviations would be prices of the same model new cars. Because you're not going to get a lot of difference between all the different prices of when they talk about the same model. Like if you went in and looked at a Toyota Tundra pickup truck, a brand new 2020, depending on the different options it has, sure, it's going to have different prices, but those prices are all going to be pretty clustered together. Same thing with heights of 30-year-olds, right? We've all stopped growing by the time we're 30 years old, so our heights are all going to be roughly the same. I mean, there's going to be differences, but there's not going to be huge differences. Large standard deviations, prices of the same model of used cars. Obviously, there's going to be a huge variation in used cars because it all depends on, if there's damage and how many miles they had and all that kind of stuff. So you can get a really big spread. So you can get a really big standard deviation. And then, of course, height of 7th graders. Well, you could have 7th graders that have big spurts, right, and ones that haven't grown yet. So there's going to be a bigger difference between those heights than there would be between 30-year-olds. So that's just some examples. Now, the coefficient of variation is basically a way of comparing apples and oranges. Because if you tell me your data set has a standard deviation of 50, I don't know if that's big or not. If your numbers were all small, like on the order of, like let's say your mean was only 100 and your standard deviation was 50, that's a huge standard deviation. But if your mean was 10,000 and your standard deviation was 50, that's a teeny tiny standard deviation, right? It's all about the scale of the numbers. So one way to compare standard deviations between apples and oranges, meaning between two completely different sets of numbers, you know, like maybe numbers that have really big values versus numbers that have really small values. Obviously, the big numbers are going to have a bigger standard deviation than the small numbers, but that doesn't necessarily mean that the big numbers are more spread out. We got to figure out what the coefficient of variation is to really compare their spread. And that's what the coefficient of variation does, is it allows us to compare those two different distributions. And it's a very simple formula. You just take the standard deviation and you divide it by its mean. So you're basically normalizing it to its own mean. And you're saying, well, if I have a standard deviation of 50, but I had a mean of 100, and then holy crap, I've got a coefficient of variation of a half. That's huge. But if I have a standard deviation of 50 and a mean of 1,000, now all of a sudden I have a teeny tiny coefficient of variation, and that tells me that my spread is really, really small, right? So that's what it does. It just normalizes it to the mean, and it lets you know basically how big your standard deviation is in terms of means. It's always going to be a decimal. You can't have a standard deviation bigger than your mean, because then that would mean you would have to have negative numbers. And when we're dealing with statistics, we're dealing with numbers in the real world, and negative numbers don't exist in the real world, right? We're either counting something or we're measuring something, and you can't count negative of something, and you can't measure a negative, right, distance or whatever. So they'll always be smaller because we don't have negative numbers. So keep that in mind. So here are some examples here, and you can, you know, get the coefficient of variation very easily by hand. And I think there's even some calculators to do it for you, but who cares? Do it by hand. It's really, really simple, easy. All right. So then it's the rest of this just talks about how you can do some of this stuff in SAS and Excel. So I'll leave that for you guys to look over. And then instead, we'll just go to the question section and see if there are any questions that you guys want to go through, you know, either on the homework, or maybe you've worked ahead, you started looking at the mini project or whatever. Let's start off with any questions you might have.
Dr. McBride, this is Michelle. Can you go over the stem and plot graphs in 3.11?
Yes, absolutely.
Thank you.
Okay, so the only way to do the stem and leaf plot is to do it with some coding. So the first thing we have to do is we have to load the data from 310, because that's the data that we use. And I always like to check my output just to make sure I have the right data. And okay, yes, this is the data from all of those states, right? And so I ran it, right? And it's now in import work. Okay, now I need to do stem and leaf plots. So I already have that program saved. But if you obviously don't, if you go to the how-to Word doc out of our Google Drive and scroll down to week 2, which starts here, week 2. So this is how you can get frequencies, this is how you get summary stats. This is the code that you need to use in order to find multiple modes, because there are multiple modes on the question in the homework, where it asks you to find the modes of those 3 sets. It asks you to find the mean, median, and mode of the 3 individual sets. Then it asks you to find the mean, median, and mode of all 3 sets put together. There are multiple modes in both of those scenarios, so you're going to have to use that code to find them, or put all the put all the data into Excel or something like that, and sort it and just find them yourself by visually looking for them. Somebody told me that Excel can find multiple modes. I have never figured out how to get Excel to find multiple modes. I thought there was a modes plural, or a mode.multi, I think it is, command, where it'll find multiple modes. So you can always try that. Because in case you didn't get the email that I sent, the school has recently relaxed their requirements, and you are now allowed to use basically any technology you want to do this stuff, including in this class. So you don't have to use just SAS. You can use Excel. You can use your calculators. You can use StatCrunch, VasterStats, Desmos, whatever you want. Just show your work. Okay, but if we scroll down, here's where it talks about how you can do cross tabulations. Here's how we can do some simple graphs when we're doing the histograms, right? Here's where I gave you some code on telling it where to start the bins and to make the bin width a certain width to try and get the histograms to look better for some of your homework questions. And I saw some of you in the discussion boards already talking about this, which is awesome. And then here is how you create stem and leaf plots. It's the only way to do it. You basically have to turn the graphics off. So this is the code that you want to run to turn the graphics off. Obviously, if you copy and paste this in, you're going to have to change the name of where your data is if your data is not in work.import. Right, yours might be in work.import2, or you might have saved it, in something completely different. So just change that, and then this will run it for variable 195, and then you can, go in there and change it for the other 2 variables. Where did that go? I think, how many variables are there? It's 95, 96, and 2002. So I think you can even have it do all of them at once. Let's try this. 1996 and var 2002. Oops. Let's see if that works. I'll just add that in. Oh, yeah, see, it doesn't like apostrophes in SAS. You always have to come back and change them. You see how they're all curly instead of the straight ones? So you always have to change your apostrophes in the code if you copy and paste it. They just, for some strange reason, they paste as a curvy one instead of a straight one. And then, of course, it doesn't recognize those things. So now let's see what happens when we run this. We should hopefully get all 3. There we go. So there's the stem and leaf plot for the first one. There's the stem and leaf plot for the second one. And the third one.
Dr. McBride, do you see how the stems have double digits?
Yes, I do, actually.
Okay.
That is wrong. I wonder how we change that.
I can, I have some code that did work.
Okay.
I'm going to put it in the chat.
Perfect. Okay, let's try this one. Okay, so I just need to change my data.
Basically, I think you add the class size equals 10.
Okay, let's see what this one does. Oh, I forgot to turn the ODS off. Sorry. Just run the whole thing. There's mine, and then there's yours. Holy moly, look at that. Well done. That's fantastic. All right. So it looks like we have to make the, it says plot size equals 10 is the big difference.
Yeah.
Size equals 10. Very good sleuthing. I love it when students figure stuff out. So let me go change that here. Plot and plot size equals 10. Awesome. All right, so let's see how this works for all three. Look at that. Single leaves, just like they're supposed to be. Awesome. Who that was from Cheryl? Thank you, Cheryl.
You're welcome.
Awesome. Great job. Yeah, it's you know, some would argue that because the data is such a small range, right? If we look at our data, the range is pretty small, right? I mean, we could run summary stats on it and see the min and max. Well, I mean, we can see it from our results here, that it goes from 37 to 76. Here it goes from 40 to 76. And down here it goes from 44 to 77. So that's why in the original one, SAS kind of said, well, let's break it up and let's look at like classes of 30s, 40s, 50s, 60s, and 70s. So if we take this away and run it, see how it's 70 and then 72. And I don't know what the 2 and the 7 means. Because we don't have decimals. Oh, we do have decimals. Okay, so that's what it's doing. It's just doing the decimals. That's what's happening. That's the big problem. Is because we have technically 3-digit numbers because of the decimals, here it gave us them as 36.4, right? 50.3 and 50.0. That doesn't make sense. It should go 0 then 3. I wonder if it's 50.30. I wonder if that was a typo or something. Because you, again, 5, 6, 2, 4. I don't know what the heck's going on then. Maybe there's 2 decimal places. Are there 2 decimal places on these things in the Excel spreadsheets? And they're only displaying them as 1? Does anybody know?
Mine were only displaying as 1, and I watched what you said before about I did the snippet with the whole thing, and then
Yeah.
I snipped it again and took only that one part that you wanted for the answer.
I just don't know why these numbers aren't in numerical order. That's just really weird.
I wanted that too, and it makes it really hard to answer. There's a set of questions later that's asking you about the difference between each year, and it makes it harder to answer it. But
Yeah, see, if we do it this way, then at least they're in numerical order. And
it
what
makes it
they've
easier to
done,
post that on your paper too.
yeah. Huh, very strange. Oh, okay, so it's multiplying it by 10. You know, there's another thing that you could do too, is you could augment the data and then run it normally. Might even be a better way to do that. So I think that's probably what I would do. So if we go to our data sets and go to 310 and open this one, I would do equals round this number, comma, 0. And then we've got 1985 rounded, 1996 rounded, and 2002 rounded. And let's see if this works. It's 310. Okay.
You are having meets tomorrow night as well, correct, Doc?
Yeah.
Okay, I'll probably tune into that one too. I was late tonight and we're having a dramatic episode over a nightlight that I had to fix. So
All right. Let's see what happens here. Okay, good. Yeah, they're all there. All right. So now let's see. This is import 1. Let's just see for giggles if this works. Import 1 and get rid of this. Let's see what it does. Nope, it still doesn't like it. Probably because of that, all those numbers still have decimals. Right? They're uploaded with a decimal. There's got to be a way to get rid of that decimal.
didn't you get rid of that decimal pretty easily last time?
Let me just get rid of it here.
It seemed like I was watching one of your meets from before and you were able to do that, and I can't remember how you did it.
Well, I did it really easily in Excel. I just forgot to do that before I uploaded the file. So that was the problem.
That might correct it though. That might be.
Yeah, this is what we need right here. Get rid of that 0. And then now we should be able to, in fact, somebody showed me this trick. If I just get this link, I think this worked. If you go to SAS Studio, and I'm gonna delete this one. And then I'm going to upload. See if that works. I don't think it does. I thought we tried it and it didn't work. Yeah, it didn't work. Yeah, that's right. So we'll just have to do it the old-fashioned way. Download it. And then re-upload it. Okay, so now if we run this one and look at our output, ta-da, no decimals. Beautiful. And, you know, we probably could have just done the same thing with the previous without having to do the round. I bet you if we just, you know, before you downloaded this, if you highlighted all of these, stop doing that. If you highlight and do right decrease decimals and turn into that, it probably would have been fine as well. But I don't know, it might still carry the decimals over when it saves. It just doesn't display them, and that's usually the problem. That's why you have to use the round function so that it actually treats it like that number rather than just displays it as that number. But in any case, now it's got it. It's in work import 2. So I bet you if we go here and change this to 2 and run this, are you kidding me? It still doesn't work. Oh, I'm using the wrong variables. R, and R. What? What the hell? It still defaults to having 2 in the stem. That's so weird.
We should get extra credit if we get this one right after we play with it.
Wow. Okay. Well, obviously, you know, you don't have to change the data. You just have to use the augmented code because obviously there's something weird going on in SAS where its default is to have 2 digits in the stem. So, okay. Very strange. I wish there was a better way to do it than, you know, multiplying by 10. Plot size equals 10. But, you know, it works. So I would just say, go for it. Do it this way. See, because this is technically multiplying everything by 10. You're doing an adjustment to your data. But it ultimately does the same thing. Just wonder, are there that many 70s? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 70s and 85.
I am lost, I
Yeah,
guess.
there's 8.
You got this one.
Yeah. See, I think it's augmenting the. Anyways, not worth our time. Let's move on. What else?
Dr. McBride, can we do 3.4b?
Sure. So you're trying to get the histogram to look good?
Yep. With the endpoints rounded or not rounded, but to the 1,000th.
The best, yeah, the best looking one I've gotten is by telling it to start the bin at 0.705 and give it a bin width of 0.05.
I tried that, but I had a gap. And it was doing the midpoint ticks. So
Yes. Yeah, I know. Import 3. So this is import 3. So import 3.
but the code, I think that I posted on the forum worked. and it didn't round or didn't cut off the x-axis to the 10th. You know what I mean?
You mean it didn't go 0.7, 0.8, 0.9, it did something differently on the scale?
So yeah, yeah,
Okay.
because you wanted the
Which
end
class
point.
are you in? 1 or 2?
Good question. I'm not sure. I'm in the Math 807.
Well, I know, but there's 2 sections. What's the last name?
Stewart.
All right, looks like you're in 2. Okay, so this code seems to work better.
No, the one below that. That was the code I had issues with, but then I figured it out.
Ah,
And it
okay.
was this one.
All right, let's give this one a try. All right, so what do we need? We need my data to be different, so work.import 3. All right.
So if you run the first one, just uncomment and then uncomment that first line, the one below that.
Well, don't you have to do frequency 3.4? Oh,
Yeah,
okay.
that was just to tell me that that top one. Yeah.
Oh, okay, so I have to get rid of this.
Yeah.
I
I think your comment on the top is right. Yeah, you can delete that or whatever. Because I was just telling you that that first line is.
Gotcha. Okay, I see what you're doing. Okay, so let's try this. Look at this, we got a fancy title and everything. Holy moly! Look at that! Well done! Well done indeed. Awesome. All right, so you just tell it the endpoints starting and ending by, okay, and then you also gave the vertical axis 0 to 9
If
and
you're
then 0 to
counting.
35 by 5. Wow, this is really impressive. You did some great work here. Okay, let me add this to our SAS how-to, because this is fantastic.
So I have a question for us dummies who don't know how to do code. What is the expectation of like that for these problems? Like if we didn't know how to make these adjustments, but we're still like running it correctly, is that still right?
Yeah, I mean, it's fine. You should really, everybody should, be challenging themselves to the best of their abilities. If you can't get it to look good in SAS, try making it look good in Excel.
Okay.
I mean, the bottom line is if you had to put this in your dissertation, you'd want it to look good, wouldn't you? So you're going to have to figure out, a way to do this. And if you don't want to figure out how to do it in SAS, that's fine. But figure out how to do it in something would be my answer. So no, you don't have to code in SAS, but yes, you have to make it look good.
Makes
Okay,
sense.
Sorry, 2 people were talking at the same time. What was the question?
I have a quick question. Now, are we with Introduction to Statistics? Are we learning, or is this something we should know already?
Learning
Yes.
what the statistics are, or how to use the technology?
How to use the technology?
No, you're supposed to be learning the technology along with the stats. So that's why it depends on, you can learn whichever one you want. You can either learn SAS, right? So we just show you how to do some basic things with the menus and some basic things with programming. Or you can figure out a way to do it with a different program.
The question remains, okay, when you say figure it out, how do we know that we need to figure this out if we're following your instructions?
Well, so the idea is that we're going to give you the tools necessary to do this type of stuff on your dissertation. So that's why I said in the beginning, you should keep, right? You should keep these program files. So if you do have to go back and make a stem and leaf plot or a good looking histogram, you now have this program file here, and all you have to do is change your data source, right? Change your variable name, go in and change your start and end points, and basically change your scales depending on the scale of your data, right? I mean, the reason why she made the vertical axis go from 0 to 35 by 5 was because for this set of data, it only ranged from 0 to 35, and by 5 makes the tick marks look better rather than, by ones or by tens or something like that. But if you had data that went from 0 to 100, you would say, 0 to 100 by 10 probably. If you had data that only went from 0 to 9, you would just do 0 to 9 and you wouldn't put anything in there because the default is by 1. But if it was, 0 to 20, then maybe you'd go 0 to 20 by 2. So it's just learning how you can kind of take this and augment it to your set of data depending on how your data is different. If you have a bigger spread, right? If there's a bigger spread of your bins, then instead of going by 0.05, maybe it goes by 0.25 or something like that, depending on the spread of your bins. Maybe you've got numbers that are whole numbers instead of decimals, then you can have the smallest, the biggest by whatever, right? And so you're binning your data here with this, you're grouping it, right? You're putting it in classes, you're putting your data into classes, or what we call bins. And so you're just learning how to do that with different data sets. I mean, it's really, once you understand the basics of what this code is doing, you can apply it to any data out there by realizing how to change these things based on the kind of data you have. Now, if you
Okay.
want to go into Excel, you can do it in Excel. And then you can make it look pretty in Excel.
I can work with that.
Yeah, so if you can work in Excel, that's fine. I'm not going to show you guys anything other than SAS because that's my job, is to show you SAS.
Oh, SAS is fine.
If you want to know how to do things in Excel and other stuff, then if I have time, I'll try and show it to you, but that's what YouTube is for. I mean, I don't want to sound shitty about it or whatever, but I mean, those were the exact instructions I was given from the chair. It said, we're going to let them use any technologies they want, but as a school, we are only supporting SAS, and as an instructor, you are only required to show them how to do things in SAS. But I have videos out there showing you guys how to do this stuff in Excel too, and so do, a lot of other people.
Where are the videos in the Google Side Drive?
No, my videos are on my YouTube channel.
YouTube channel. Oh, you're covering all this stuff there too?
I cover mostly just stats and math. I don't do a lot of SAS stuff on my YouTube channel. I do have some of my SAS videos are out there, but most of my videos on my YouTube channel are just how to do math. And then I use technology for that. So sometimes I'm using Excel, sometimes I'm using SAS, sometimes I'm using the TI calculator, sometimes I'm using StatCrunch. It just depends. But I mean, if you want to learn how to do something in SAS, just go to YouTube and type in SAS and then whatever you're trying to do, and you'll find stuff that'll show you how to do it. And Excel's even better because there's thousands of Excel experts out there making videos all the time. Far more than there are SAS ones.
So basically on the 3-4, dividing the range by 7, did we cover that by 7?
Well, yeah, I mean, dividing the range by 7 is just a simple bit of math. All you got to do is go into summary statistics, right? Open up statistics and summary statistics. And we want to run it on, wait, this is for 3-4, isn't it? So we want to run it on 3-4, which is import 3. So choose import 3. Your analysis variable is fluoride. And then if you go to your options, right, this is what it gives you, this is what it defaults to. But if you go to additional statistics, you can do range, and it'll give you the range, right?
Yeah.
And then if you run it, so there's my range, 0.33. And then if you divide that by 7, then that gives you, your starting bit. So if you take 0.33 and divide by 7 and round, you get a class width of 0.05. And so then that's where we get this 0.05 for the bin width, or in down here in this one, that's why they said by 0.05, because that's how wide we wanted each class to be, because we wanted 7 classes to our data. Now, if we wanted 10, then we would have divided 0.33 by 10 and we would have got basically 0.03. And then we could have done that. It just depends on, how many bins you want, how many classes you want. Okay, what's next? We've only got 10 minutes.
Okay, so number 7.
Anybody?
Can you show how to upload the files? Because I don't think mine came out that well.
Sure. So under the server files and folders, under the files tab, you should have a SAS user folder. If you want to, you can create 2 new ones by right-clicking on files and doing new folder and then giving it a name. I would suggest doing that, and I created a data files folder and a program folder. Once you've created your folder, if you just click on that so that it's highlighted, all you have to do is hit this little upload button and then go and find your data file, right? So I hit upload, choose files, and then for me, I downloaded it to my desktop, right? So on desktop, here is the 310, right? So I would double click that, it puts it here, and then hit upload, and it'll upload it to that data. It'll upload it to that folder.
We're uploading one at a time.
Nope. Now, if you have them all in one place, you can highlight all of them.
Is that correct? One file at a time?
No,
Or
if you
can
have
repeat
them,
that?
if you have them in the same folder, you can highlight all of them. So for instance, when I did upload and choose files, I could choose this one, and this one, all of my Excel files,
Mhm.
and it would upload all three of them at the same time.
Okay, I have it. Thank you so much.
Yep.
Now, it's my understanding that if we want you to look at the answers we have for the homework, we can submit that to you and you'll make recommendations. Is that correct?
You can email it to me no later than, I'd really like to have it no later than Thursday night by midnight. Yes.
I'm going to say mine is done. I'm kind of trying to go over it to make sure it's done right. So I'll send that to you as soon as I can.
Sure. No worries.
Yeah, I want you to look at that. I'm having a lot easier time this time around, by the way. I highly recommend taking it twice.
Yes, it does help taking it the second time around. Absolutely.
Well, not being suicidal sort of kind of helps too.
Yeah, absolutely. That helps with everything. All right, 8 minutes. Any others?
Yeah, well, I don't know if we can do it in 8 minutes. Maybe you and I can have a one-on-one, Dr. McBride, because I was working on the mini project.
Yep.
And I have some code for the Pareto chart.
Yeah.
It's not the code you provided.
Okay.
So I wanted to go over that with you.
Okay.
It's basically like a vertical bar chart
Yeah.
with an overlay.
Sure. You know, the mini project's coming up, people should start thinking about it. So unless somebody has another question on the homework, I think it'd be a good thing to talk about right now. Are you using the full data set, the new drug data for the Pareto chart? I can't remember.
Yes, I am.
Okay. All right.
Because I had to, actually there were two, so I had to look and see which one made more sense because I didn't know which one we had to use because there were two. But
yeah,
then ultimately it made sense to use that one. Yeah.
Yeah, the BP categorized is the one that you have to use when you have to do the side-by-side box plots.
Oh, okay. I think that's what I did.
Yeah, so to do side-by-side box plots, you have to use the BP categorized version of the data.
Okay.
But anyways, you want to paste your data in the
Or paste
chat
my
box?
data?
Yeah, and I'll give it a whirl.
Yes. Chat box. It's coming right up.
Let's see. Save as. There's a new one. Add to my snippets. Okay. So let's do this. All right, does that look right? That's your data, the mini Newberg stuff?
New drug, yes. I think
Okay.
I have to change that.
Yep.
Because what I do is read that data in and then save it out to a temp data
Yep.
hole, data store,
Yep.
and then take that data store,
Yep.
right?
Yep.
And then that's what I run the count or the Pareto chart on.
Okay.
So I'm not actually running it on the original data set.
Right, you're running it on the output.
Yeah, exactly.
Okay. Let me just change this to mine. Work dot import. I think it's 4. All right, let's see what we get. Okay.
You cannot put that out to your work folder because you may not have a Math 807 folder in your library.
Okay. Yep. Okay.
So just change that to work.
Work. Yep.
And that's work. Yeah.
Yep. Okay, and then
that's
this
work.
should be work.
Yeah.
All right, let's try it again. Yeah. Looks good. Now,
But I don't know what that means in terms of analysis.
well, a Pareto chart, all a Pareto chart is just a bar chart where it lists the bars in descending order.
Okay. So does that mean that chart then says all of the patients or the majority of the patients got their high blood pressure from their dad's side?
Well, it just tells you that the more of them did. You know, I wouldn't say all, and I couldn't even say majority, right? Because
Okay.
it was only, 14 out of 45 type of thing. I mean, it's barely higher than the maternal.
Okay.
So it basically just ranks it. I honestly, I like the simple one here by just going through the menus, statistical procedures,
And it did,
because
yeah.
I think this gives it to you horizontally, and I think horizontally looks better than vertical.
Okay.
So,
By side.
sorry?
Can we run that Pareto chart? That
Yeah, yeah. Okay, so statistical process control, Pareto analysis. So work import or, and the variable,
FamHist.
is it family history?
I think so.
Yeah, that sounds right. Yeah, so you see it looks just like yours, only fatter, right? Because it's horizontal.
So, but the count is off on that one.
No,
That's
because it's in percents.
percent. Got it. Okay. Yeah. So we can just change that. Okay.
Yeah, you can totally change
Cool.
that. And either way is totally fine, Cheryl. And I love that you're playing around with this and finding code. It's awesome, and keep doing that. But sometimes, we can spend all this time and energy finding code, and I don't know about you, but I don't think that's any better
Right.
than that. I mean, it might be. I mean,
No. You're right. Yeah.
some people might really like them vertically.
Because I had to Google what a Pareto chart was. To be honest, I had no idea. I don't even know what that line means.
The line is your cumulative frequency, or in this case, cumulative percent, right?
Okay.
So for both of these put together, we're now at 25, right? Cumulative percent is, you can see here, cumulative percent pops up. Cumulative percent 54, and then cumulative percent 80, and then finally, obviously, cumulative percent 100 for all of them. So it's giving you a cumulative percent thing. And then I wonder if on mine it's doing a cumulative count, right? Because yours is doing count, this is doing percent.
It's on count on top. It's count on top, percent on the bottom, and yours is count on the right, percent on the left. So it's just skewed, because mine's horizontal, yours is vertical. Same
exactly. Yep,
yeah.
You got it. Yeah. So yours has these nice little cumulative buttons that mine doesn't, right? But I think you can get that through some of the options.
You can even make them horizontal here. That's awesome. Hit the horizontal.
Yeah, there you go.
Yep.
So, yeah.
Okay, cool.
Yeah, it's funny. A Pareto chart is really kind of silly and stupid, in my opinion. I mean, it's useless other than just showing you rankings of your categories, right? Which one had the most down to which one had the least. And I really always found that the only time a Pareto chart was useful was when you had a lot of categories. I mean, 4 categories, give me a break. It doesn't really help much. But if I had like 7 to 10, then it would be nice to rank them. And especially when there's bigger differences than this one, right? I mean, there's not a lot of difference in the categories. But again, it's just another way of just displaying and describing your data. Let me just mention this again to everybody. Somebody had showed up late and apologized. Please don't bother. Remember, these things are voluntary, so if you show up late, that's fine. Don't worry. Don't feel like you have to apologize. Also, if you need to leave early, that's also fine. And that you know, even like right now, we're at 6:02, and we're talking about Pareto charts in the mini project. If you feel like you don't need to listen, then log off, right? I mean, it's just, I'm here to help. These are voluntary, so you know, you can kind of think of it as like office hours. You don't have to go to office hours, and you don't have to stay the whole time. You can always go back and watch the videos later. So I just want to make sure that everybody knows that you're not trapped. Don't feel like this is a Zoom meeting that you have to go to, right? You have to attend and you have to be there the whole time. You can pop in and out freely. You know, whatever you feel is best for you. Obviously, I would love to see all of you show up for both meetings every week for the whole hour, but you don't have to. So I just wanted to point that out one more time. Okay, we are 2 minutes over, so unless there's a quick one, I say we call it.
All right, can we
I
schedule,
have.
Sorry, go ahead.
can we schedule like an hour meeting with you sometime, or?
If you want to schedule a half-hour meeting with me, yeah, just send me an email. We'll try and figure out a time where we can meet.
Oh, thank you.
Okay, and then was there a list of the teams? Because I looked for a list of who was on which team, and
No, I talked about this in week 1. I don't assign groups. So if you want to be in a group, it's not mandatory, it's voluntary. So if you want to be in one, just create one or jump into one. Otherwise, you don't have to.
okay.
Anything else? All right, everybody, thanks for showing up. I'll see you either tomorrow or next week.
Bye. Thank you.
Yep.
Thank you.
Thank you very much. Bye-bye.
You're welcome. Good night.
Thank you.